And we're talking about division patterns. So just like when you multiply, and there are patterns when you multiply, there's also patterns when you're dividing. So we talked about the fact families at the beginning of this chapter, and how fact families help you to see the pattern, because if you find those three numbers, you know it's going to be it's going to be those three numbers that are going to work together, and those are going to be all the pieces of the puzzle, all the pieces of the problem. So our essential question is the strategies that are used to divide whole numbers. So we've learned the fact families, we've learned to draw some pictures. Yesterday we learned the algorithm, or the steps in solving the problem. And then today we're going to learn about some patterns that can help you when you're dividing. So these are some of those tricks. We're not learning new thing on dividing, because dividing is just dividing every time. It's going to be the same every time. But today we're just going to learn some strategies and some tricks that when you see problems that look like this, what are ways that you can solve them a little bit more easily, or solve them in your head. So you should have a whiteboard from this morning still at your table. Before you start moving around to grab it, let me look this way. Look this way. Zen Station and everyone in that group, look this direction. Did you not? You heard the first part of my sentence, but you did not stop to hear the last part of my sentence. I said on your whiteboard that you got this morning, and if you don't have one, please wait till I read the question before you hunt for it. That's what I was saying. But you guys all started moving around and you didn't hear the last part. Listen to my whole sentence. I'm going to read the question, then I'm going to give you a second to solve the problem on your board. If you don't have the board right now, you're just listening. You're just listening and looking anyways. You're not writing yet. So just listen, look up at the screen, and then in a second, if you don't have a board, you'll get one, and then you can solve the problem. So it says, a flower shop received a shipment of 14 cartons of flowers. Each carton contains 20 boxes. Each box has 30 packages. Each package has 2 flowers. How many flowers were in the shipment? So you have 14 cartons. This is going to be a carton. You have 14 of those. Inside the carton, you have 20 boxes inside of there. Each box has 30 packages, and each package has 2 flowers. Okay, so for every carton, inside of the 14 cartons, inside of there, you have 20 boxes, and each box has 30 package, and each package has 2 flowers. So the way the question is written goes from biggest down to smallest, and you have all these things inside of each other. But we're going to have to work backwards when we solve this problem. So think about how many flowers are in 30 packages. Once you get that number, how many packages would be in 20 boxes, and then how many boxes are in 14 cartons? Because the question is how many flowers were in this shipment. So you have to think, it's kind of like a working backwards. So if you don't have a whiteboard, make sure that you get one to work this problem out. All right, so Catherine, see if you can explain to us what you did. I'm going to try to write what you say.
Okay, so I did the 14 cartons times 20, and then I got 80, and then
wait, 14 times 20.
I just lost 800. I got what? 200. I can do it.
She did 14. Hold on. So she did 14 times 20. So the cartons and the times the boxes. So let's see. So that's 280. And then what did you do next?
And then I did 280 times 30.
So 30 was because of the 30 packages. So 280 times 30. And that's 24, and then 6, 8. So you got 8,400, right?
Yeah, and then I did it times 2.
Then that number times 2. So I did see some different strategies out there. So some of the strategies I saw were some people were trying to draw things like you have 2 flowers in this shipment. Each package has 2 flowers, because you could go the other direction too with this problem. You could work backwards, and you could say because of 2 flowers in each shipment, there's 30 packages. So you multiply that, and then you could multiply that by the 20 boxes. Like, you could go the other way too, because multiplication works either direction, right? All we did in this whole problem was we multiplied. So if instead we worked backwards and did our multiplying, we should get the same thing if we worked backwards. So our final answer is 16,800 flowers. Raise your hand if you got 16,800. Sometimes it was hard to explain how you got that answer, but if you got that, raise your hand. All right, awesome. Some people had it, they were really close, and they were missing like one little part, like maybe forgot to multiply by 2 at the end or something. Yeah, sometimes you get one little part, and then that messes up the whole problem. Okay, so let's look at strategies that we use to multiply numbers that are multiples of 10. Just waiting for you to not talk. This is that part where you have to be quiet because you're listening to the lesson. So, all you have to do is erase your whiteboard. If you don't have an eraser nearby, then just wait, because nothing's going to happen bad to your board if your work stays on it for a minute. I need you to look at your notes. So on your notes, I want you to write Chapter 3, Lesson 4, and the title is Division Patterns. Here's a couple things that you need to know. Write this in your notes. Writing this? Yep. So, lucky for you, this lesson is really similar to a lesson that we did when we multiplied, except we're dividing, not multiplying. So this is our powers of 10 lesson. Okay, so a lot of what we're going to do here is some division in our heads. Okay, so the first thing you need to know is that when you multiply 2 numbers, well, let me be more specific. When you multiply 2 whole numbers, your number gets larger because you're multiplying them, you're making them bigger. When you're dividing 2 whole numbers, the number gets smaller. So when we're dividing it, we're making the number smaller. So that's a good way to check your work at the end, is to make sure that when you're dividing, your number is actually getting smaller. So for the first example I'm going to give you, if I'm dividing 60 divided by 3, my number should be smaller than 60. Think about that for 1 second. So without anybody talking, including me, I'm going to say the sentence one more time, and I want you to just think about it. So use your brain muscles just for a second and think about this. If I'm telling you the question is 60 divided by 3, because I'm dividing, your answer, the quotient, has got to be smaller than 60. Think about it like this. Think about it for a second.
I know it.
Did you have time to think about it? If you're dividing into a number, I'm making that number smaller because I'm breaking it up into groups. So if I say I have 60 pieces of candy and I have 3 people I'm going to divide that candy between, obviously everybody can't have nobody's going to have more than 60 pieces of candy. They're all going to have less than 60 pieces of candy because I'm dividing it amongst 3 people. Okay? So here's what you do. And then we're going to do this one example, and then I'm going to write something that you're going to have to copy down, and then we're going to do some more examples. So just like when we multiplied, When we divide, we're looking at the non-zero numbers. Write this down. We're looking at the non-zero numbers. So in this case, it's 3 and 6. So I'm going to divide, imagining that that 0 is not there. So I'm going to divide 3 into 6, and I'm going to get 2. And then I put that 0 that's left on the end. So if I were multiplying, listen, keep listening. If that were a multiplication sign rather than a division sign, I would take those two non-zero numbers and I'd multiply them, and then I'd add the 0 on. But because I'm dividing, I'm going to divide the two non-zero numbers, and then I'm going to add the 0 on. Okay? This is what we're doing in our lesson today. So this is another tool and strategy to dividing whole numbers. Is this going to work every time we have a division problem? No. It's only going to work when you have a number that ends in a 0. So when you have a number that's a multiple of 10, that's something that you can do. So here's what I want you to write, and then I'm going to answer those questions. Write this in your notes, please. This is a lot to write, but it's important. This is kind of like your steps. This is what you're going to refer back to, because the problem that I just gave you was one of the easier ones, and then I'm going to show you what some of this means. So here's what it says. When we divide multiples of 10, you divide the non-zero numbers, and then you cross out 0 pairs. And then you add the zeros to the quotient. So the last example that I gave you, which was 60 divided by 3, we had the 6 and the 3 as the non-zero numbers, so we got a 2. And because this is not 30 here, there isn't a 0 after the 3. There aren't any 0 pairs to cross out. So I'm going to show you an example next where there are. So then I could just add that 0 to the end. So that was our first example. I'm going to give you a minute to copy that down before I delete it and go on to the next slide. If I have 60 divided by 3, here's what Bryson said. If I'm dividing 3 into 6, I get 2, and then I add that 0 on and I get 20. If I'm doing 60 divided by 30, it's basically the same thing, except I'm still dividing 3 into 6 and I get 2, but here's where crossing out the 0 pairs comes in. This number has a 0 and this number has a 0. So I'm crossing out the 0 pairs. And if there's anything left over, any zeros that are left go on to the quotient. That's what the rule said that we just wrote down. So for an example, like this one, 600 divided by 30. I'm using the same basic fact every time, but I have 3 divided into 6 is still 2. And then I have a 0 here and a 0 here that I can cross out, but don't I have still 1 0 left? That becomes part of the answer. So you can only, listen, I like the light bulbs, you're getting it. If you only have 1 0 in one of the numbers, you can only cross out 1 0 in the other number. So it has to be even. Otherwise, that trick isn't going to work. So if I have 6,000 divided by 30, I'm still dividing 3 into 6, which is 2. And this 30 has 1 0. Can I cross all 3 of these zeros out?
No.
I can only cross out 1. And so my answer would be 200, because those zeros become part of my answer.
Oh, that's cool.
So did you get how listen. This goes with, remember the first thing we wrote in our notes? Look back up. It said multiply, your number gets larger. Divide, your number gets smaller. When I see everybody going, oh, I get it, this is easy. It is pretty quick, but there is a way that you could accidentally make a mistake if you're not paying really close attention. So it's important to remember that since we're dividing, your answers are always going to get smaller. So if my biggest number here is 6,000, my answer shouldn't be bigger than that. My answer is going to always be smaller than that. So think about, is my answer reasonable? If I have 600 and I'm dividing it by 30, 20 seems like a reasonable answer. And I could take my quotient and my divisor, so this number and this number, and I could multiply it, and I should get the other number as my answer, right? Because you could always go back and check your work, which is going to ask you to do that today. So if I do 200 times 30, and I use the multiplication patterns that I learned, 2 times 3 is 6, and there's 3 zeros, and so I get 6,000. So do you see how those two problems, you can actually go back and do the opposite and check your work? Okay? Any questions so far? So you're crossing out the zeros that they have in common, but if there's zeros left over, those become part of your answer. Malachi.
What if I'm like doing 7,000 times, let's just say divided by 50. Let's just say that.
7,000 divided by 50?
Yeah. Would it be 7 times 5? Or would it be how many times 50 That'd be a hard one.
I'll wait for you to be quiet to hear the rest of that question. He says, what if I'm dividing 7,000 by 50? That is a question where this strategy isn't going to work. Anybody know why this strategy wouldn't work? Why not?
Because you have to do how many times 50 will go.
You would have to be dividing 5 into 7. Does 5 fit into 7 evenly?
No. That's
So,
what I'm trying to say.
right. So that question, you could figure out the answer to that question, but that would be a long division question because you can't do this short trick if the number doesn't go into the other number evenly. And so what you're working on today, they should all go evenly because this is what you're practicing today. But in the future, like if you get a test or something and you saw this question on there, this would not be a strategy you'd want to use. Okay? Let me show you another example because this part's important. This is going to help you on your assignment. Write this one into your notes because I'm going to get a bunch of people asking me about this type of question as soon as we get started on our work. So the question is 2,000 divided by 5. So what are my non-zero numbers in this question? 5 and what else?
2.
Can 5 go into 2?
No.
Okay, so what should I do? Nolan, you got your hand up. What should I do?
Instead of 5 and 2, that would not be your non-zero numbers in a way. It would be 5 and 20.
So because
But then I should have non-zero number.
you're right. So that's why I wanted to put this one in here because they do have some in there like that. Normally, you're just using the non-zero numbers. But in a case like this, 5 doesn't go into 2, but 5 does go into 20. So see how I did the underlining? 5 goes into 24 times. And then these 2 zeros would go on to your answer. This 0 right here is part of the 20, and so you've already used it. So you wouldn't use it again. So,
Recess?
no, that's not our class, and we don't need to worry about it. Sure, thanks. So 2,000 divided by 5 would be 400 because you're going to take the 5 and you're going to divide it into 20, not 2. So you have to really look at those first numbers. It's either going to be the first number or the first 2 numbers, one way or another. Jameson.
Are we going to have 2-digit numbers on our paper?
On this number here? Yeah, I don't think so. You should only have 1 digit on the outside, hopefully. Sometimes they throw 1 or 2 in there that are a little bit different.
They do.
Oh, they could have 2 digits, but one's going to be a 0 usually.
Yay!
So, yeah, you might have
this one
2.
has more than
Like if it was 2,000
This has more than that.
divided by 50, then you would go 5 goes into 20 4 times, and then you could cross out a 0, and then your answer would just be 40. Or you could even do 2,000 divided by 500, and you would just get 4. Okay? Because you'd cross out some more zeros. All right, look over at your math page really quietly so you have enough time to work today. That's good, Bryson. We're secure. Thank you. Example number 1. Showing me you're ready if I can see that you've got your math paper in front of you, your eyes are on the screen, your pencil's in your hands, you're ready to write. A monarch butterfly can fly 240 miles in 3 days. Suppose it flies the same distance each day. How many miles will it fly each day? So it's 240 divided by 3. So remember, we're looking for the basic fact. See how they've written it in here? You're looking for the non-zero numbers, the basic fact. In this case, it's 3 divided into 24. So the way they've written this, unfortunately, is super confusing. So we're not going to use all of these boxes. They're showing you the patterns. Like if I put zeros in there. So do this on the side. Do this on the side of your question, exactly what I'm writing up here. 3 into 24 is what? 8. Sorry, Angelina, you had your hand up. And then, what do I do with the 0, Angelina?
You put the 0 right there.
Put that in next to what?
Next to the 8.
Next to the 8. So you're going to put the 0 next to the 8. This time we didn't have any zeros to cross out because our number that was our divisor only had one digit. It didn't have any zeros in it. So the butterfly can fly 80 miles each day. Fill that in. Amazing, right? Okay, example number 2. A cow eats 900 pounds of hay over a period of 30 days. How many pounds of hay would it eat each day at this rate? So 900 divided by 30. So with all the boxes, they give you like 2 different ways. And so one way is using all of these boxes and using their fact family. See, it says use the fact family of 3, 3, and 9 to help represent the problem. I don't really see I think this should really be done like in your head mentally because that's what it's really made for. So in your head, you can think of the fact families 3, 3, and 9 because that's what the numbers are going to be. But when you're dividing 3 into 9, you're going to get 3. Then I would cross out this 0, cross out one of the zeros over there because remember it has to be equal. If you cross out one from one number, you have to cross out one from the other number. And then I've got 1 0 left that would come over here to the end of my answer and make 30. Why is it not 3? Someone explain why it's not 300. Tristan.
Because if you take the 0 off of the back of the 30, then you have to take a 0 off of the 900.
Because I took a 0 here, look up at the screen. Because I took a 0, this 0 right here, I had to take a 0 from here. So I crossed them out. And so there's only 1 0 left on the end of 900, and that becomes part of my answer. So that's why I get 30. Understand? So to get 300, I would have to have 2 zeros that I didn't cross off. Okay, so one way is to use the fact families, which is kind of like what we did, but in our head. Another way is what we did. We used the pattern of the zeros, right? So everybody kind of thinks a little bit differently. So you're probably somewhat using a fact family when you're thinking of 3 into 9. You're thinking of a fact family. But you're not necessarily writing it all out. So the answer would be 30. So the cows eat 30 pounds each day of hay.
Oh my God.
So I'd like you to try the guided practice with your group. And then once you've checked it, you may start your independent practice.